Welcome everybody to another session of Demo Days. Today, we're going to be routing OSQuery events and sending them to Pulsar from a EC2 instance. So what is OSQuery? Well, basically it is a tool that you can install on your laptop or any desktop computer, as well as like an EC2 instance in AWS or for some virtual machine. What it does, it basically creates a way for you to query those like events that are happening on your operating system, on your OS, as tables and with SQL. So it's like very much like Decodable on streams, but OSQuery is a SQL on your operating system that allows you to query and pull information that you might be interested in that operating system. What we're going to do here is actually forward that data, those events, to Apache Pulsar. And then we're going to use Decodable to read that data off of Pulsar and route different messages to different destinations based on some, whether they're noise or some, if they're suspicious, or if we just want to look at it in some real-time database. Okay. Some of the use cases you may want to use this for, this whole solution, is to just basically monitor your operating systems or find any vulnerabilities if there's like suspicious activity happening on your operating system. OSQuery is a great way to kind of capture that information, and then Decodable is a nice way to kind of route it to the destinations you need them to go to. The way this works is when OSQuery is installed on your operating system, there's a thing called an OSQuery extension that does the forwarding to Apache Pulsar. You can forward this to any kind of thing, right? Most likely it'll be some streaming platform like a Pulsar, Red Panda, or Kafka. In this case, we're going to use Apache Pulsar. And the extensions can be written in several languages, C. In this case, we're using Python, and this is the extension here. It's very, very simple. There's two plugins here. One to configure OSQuery, to tell it what to do, basically, and then one to handle the messages coming in. Okay. I'm not going to spend too much time on this. You're welcome to download this example from our GitHub repository, which I'll show you momentarily. But just a brief overview here is there's a query. This is the query that I'm going to be executing with OSQuery. OSQuery will then listen to this table, which really lists all the processes that are running on an operating system. So what we will do is look at that information in Decodable to see if it looks suspicious. So we have a list of known processes, and if they don't fall in that list, we'll just consider it suspicious, right? At this point, we probably don't know every possible process that could be running in your operating system, so we may have to tweak our SQL statement to let some of those processes go, but there's probably going to be some that may look suspicious to you. Okay, so this is the extension, and what we'll be doing, this is the entire pipeline. So as you recall, there's an extension on OSQuery that's sending data to Apache Pulsar. We're going to use Decodable to pull that data out of Pulsar and get rid of some of that noise. And I'll show you what kind of noise we're going to get rid of. We'll also split some data off that may look suspicious. So that may end up in your use case for to be viewed by some threat hunter to investigate, or into some alerting system. But it doesn't matter. You could send these messages or these logs to a place where you can react to them pretty quickly. And we'll send the rest of that data to some other database. Right now, I don't have that database set up. Outside of our scope. Maybe the next demo days, we'll actually add a real-time database here to kind of show what's happening with the OSQuery activity, or the activity that's happening on an operating system with OSQuery. Let's, at this point, I think we should go ahead and start what's that OSQuery on our EC2 instance. So this is my EC2 instance. I should have in my history here a command. So I have this command better visible here. This is basically the same pipeline in the GitHub repository. And this is the command we're running right here. This is just telling OSQuery to run in the foreground. Typically, you could run it in the, typically you want to just run this in the background, unnoticed, do your thing or run your application, right? But in this case, we're telling it to use this Pulsar extension to send data to Pulsar. And then we're telling it different, which logger to use, which is our extension, and which configuration to use in our extension. And these other ones kind of just allow you to use these in a way that, you know, I want to have my Pulsar extension ran locally. So normally you want to put these in a safer place in your file system. But this is the command that we're running here. Let's do that now. So this is now running and sending messages to Pulsar. What's happening, I think the best way to really visualize this is to go through the lineage graph in Decodable. So this is our connections page. I have two connections here that are running. So sorry, I'm just refreshing the page. I have a Pulsar source and I have a Pulsar sync. And when I click here, notice there's one outbound stream. So hopefully we'll see these OS query logs come through. We do. And let's take a look at what's the content. So let me show you the schema really quickly so that you can understand what this looks like. So this is an example. This is the JSON's query or schema. And here are the columns. There's a field called columns, and these are all the properties within that column. So it's multi-level, basically, right? You have your properties up here, and then this columns field is actually an object that has more fields in it. And if you go back here, you can see an example of what some of these messages look like. They all look the same, but if you were to query another table, it'll still have the same format, but different columns, most likely. So if I were to query like files, be open files, for instance, in OSQuery, there's a table there called open files. I believe that's the name of it. That obviously it'll have different columns, but the shape of it, of the message is still somewhat the same, just the columns will be different. So we saw, just move things around here. We saw messages come in, and you notice that there's a lot of OSQuery information, you know, logs in here. And this is not something that we really care about. We know that OSQuery is running here. So how can we, what can we do to kind of clean this up so that if I were to do a machine learning, training a machine learning model with this data, it probably wouldn't perform very well because I'm giving it a lot of, you know, messy data. There's a lot of noise here. So let's go to our pipeline. And this pipeline, what we're doing is going to try to filter out some of that noise. And this is the SQL. So basically what I'm doing is I'm looking at the command line field in the columns field, right? So a Decodable really knows how to understand how to read JSON just using simple like these dictionary-like approaches to pull complex fields out. So it's looking at that field, like it's anything that looks like or has the term OSQuery in it, just filter it out. I just happen to know that some of these logs that have nothing in the command line are also related to OSQuery. So these are all being left out of the result. So when I go out here, this is the stream. So we're back into the stream. So going back to this picture again, what we're seeing here is the noise come out. and now we're only seeing better, at least better logs, right? So we're seeing things like Jetty, something with a init. Since in EC2 instance, we have some Amazon things running, and so on, right? So now we're in a place where we could actually do some stuff for it. I could actually send this to some training model to get it familiar with what's running on some of these OS EC2 instances. So I have two options here. I click this. I have two pipelines that these are SQL statements that I'm going to run against this filtered process. One, I'm going to look for suspicious processes. And second, which I'll get to subsequently, cleans up this data so it could be used in some visualization and aggregated pretty easily. Right now, everything is a string. If you look at the schema, everything is a string. Even in the contents of the columns, everything is a string. But obviously, like things like disks, bytes, those aren't string, but they should be some kind of like number data type. Just like this, the counter should probably not be string, and so on. As I said, just bytes. So that's what the cleanse is going to do. But let's first look at the more interesting one, the suspicious processes. So this is a pipeline that's looking for suspicious events or processes in the OSQuery logs. So this is pretty simple. It's just looking for values in the command line that don't have these values in it. Anything with Amazon, and then we saw all of these in the logs, and they're things that we expect to be running and not really suspicious. But it's good to kind of train on these models if you'd like to, so that it's familiar to that model. And also, if I wanted to monitor these processes on a dashboard, I'd probably want to keep them, but not really consider them suspicious, which is what this query is trying to look for. So what does that look like? There might not be a whole lot. I'm going to go back to that. So this is the stream that this SQL is feeding to. There's probably not a whole lot in here. There's probably things that I just forgot to put in that list of approved running processes. So I'll probably take some of these things and put them in there next go around. Well, let's run something that shouldn't be probably ran, right? So let me run open up another tab, and let me get that SSH command. So let's just run something that's not something we would normally run on this instance, like top. Right, so top just is like your control center here. It kind of tells you what's going on in the operating system, what things are running. What does this look like when it passes through our system? As you see, the top was already coming in. It is a suspicious process. It's probably not going to be on the list of approved running things or processes on your operating system. Likewise, if somebody does a find through your file system, these could be suspicious things. Somebody's looking for stuff, right? And like you see, top is appearing here. Some of these, if I were a threat hunter and I see some of these other things that are running, I would probably put them, to be put in a list of things to ignore. But these top things, this would probably make me want to go find out what's happening to this EC2 instance in AWS. Right now, it's got no outputs, but I would probably put this in some alerting queue or some threat hunter's queue, so that he or she can start to investigate. So let's step back. We're back to our process here, and then we're back to our filtered processes. We had those two pipelines emanating from this stream, and one is the cleanse. So let's take our look at that pipeline again. So we have the suspicious pipeline going to a threat hunter possibly, but now we want to take all of the logs and send it to a database. But as recall, a lot of that data is all in string. We want to clean that up a little bit. So that's what these OSQuery cleanse is going to do. It's a bit long, but cleaning data is never fun. It's always something you have to do. Is repetitious, but the stuff you have to do. Basically, I want to convert the values here and cast them down to their actual values, so that when they reach the downstream real-time data, they could do real aggregations on them. I mean, I won't be able to do a sum or a count, or I can do a count, but I can't do a sum on a string. I would have to convert cast them down to their actual data types. So what does this look like? So this pipeline here is going to feed to the stream. And notice everything is now flat. If you look at the command line, it used to be within a child of the columns element. All the numeric fields that were previously string are now numerical or big int or integer. Now I can start to do math on these logs. And if you recall, I kind of missed that when I was looking for suspicious things here. I had to actually cast one of the fields down here. I have I'm looking for anything that's running longer than a day, and I had to downcast that to an integer here, so I could do my math here, right? When I get this data, when I clean this data for the downstream real-time database, this is already be done. It'll be inserting it into their tables and maybe creating a materialized view and doing an count and so on. Okay. I do want to quickly go through the code so that you guys have some reference here, how easy this is to do. There is a consumer Python code script here. This reads Pulsar in case you wanted to debug Pulsar. I left a consumer here for you to use. This is that Pulsar extension. Very easy to use. The one thing, if you want to use this locally, I would change this path here so that it points to your own environment file, so that Python can load those values and set the credentials here when connecting to Pulsar. Okay. Here's some requirements. The .env uses the environment variables. There's the OSQuery, as well as the Pulsar client. Okay. And that's it. It's very, very simple pipeline to really put together. I would believe the hardest part is just installing and getting OSQuery working. After that, this whole pipeline is really simple to set up.